Hey guys, welcome back to another episode of DIY Chris. I am Chris, and in this episode I'm just going to really quickly go over my new product that I just released. Basically what this is it's an EEPROM that can replace any of the Commodore 64's 2364 or 2332 ROM chips. That would be the basic ROM, the kernel ROM, the character ROM, and this will work for all of the long boards. The short board is a little different because it uses a larger ROM chip. Okay, it uses a 23128. So this EEPROM that's on here is 64K, so it can accommodate up to a basic or a kernel ROM and also a character ROM, which is actually half that size. It's 64 kilobits, so it's 8K, and so each of those images is 8K, and then the character ROM is actually 4K. So previously what I did is I used to sell these, and do I have one available? Well, sorry, we can't really do any show and tell because I'm not prepared. So, anyways, the previous versions of this actually, the way they work, first of all, let me break this down another way. The EEPROM chip that's on here has 28 pins. The ROM chips that are in the C64 are 24 pins. So you couldn't fit one of these chips into one of those sockets. Now this chip, a particular package of this chip, is called an SOIC28, and that is the designator that tells you how the size of this package, right? So it's SOIC 28 because 28 pins. Small outline or small inline outline over, I forget what SOIC stands for, but it's small something something chip, I think. So anyways, the way this works is the layout of the pins is completely different. Well, not completely different, but they are slightly off from the 24-pin ROM chips. So what you have to do in order to get this to work is, well, actually what people would do before they, I guess, came out with these smaller ones, is you could take a chip like a W27C512, which is actually 512 kilobits, which actually can hold up to 64K of memory, which means that you could put a total of 8 images onto one chip, right? But what you could do is you could take that chip and then you could create an adapter for it that would rewire the pins to different locations to where the C64 would then understand, okay, well, you know, here are the address bus lines, here are the data lines, and here are the here's the voltage, the ground, and all that stuff, so that the chip can communicate. So it's not a direct mapping from one chip to the next. Number one, because there's 4 additional pins. Number two, because they're in different spots. So 2 things that you have to deal with. So what I did initially is I created this adapter, and I would take this chip, and I had an adapter that I could put into my programmer to program the SOIC28 package, and then after programming whatever was going to be on the chip, I would then solder it onto the adapter, and then solder these pin headers, and then the chip would be ready. So it would be a basic chip, or a kernel chip, or a character chip, okay? So I was never really satisfied with that because literally what we're doing is we're taking the flexibility that an EEPROM provides, which is to be able to be erasable and then reprogram to whatever you want, right? So we're taking that and we're kind of just throwing that out of the window because we are taking this chip and we're solidifying it to this board that is wired this way, and you can never take this then and put it back in a programmer because, number one, you're giving up 2 pins that are critical to the programmer, because the programmer needs to be able to set these pins when it's writing to the chip, and one of those is actually the write enable pin, and the other one is a chip select, so chip enable. Basically, those pins were gone, and then the other part is that the pins were routed to different places, right? So 2 hurdles to overcome. So what I ended up doing is I decided, you know what, I'm going to redesign this chip. I'm going to make it so that this chip, once this EEPROM is on here, can still be programmed. You can still put whatever you want on it, okay? So obviously there's some issues that go with that. One, the pins, the write enable and the chip enable pin, okay, they are specific to they're actually inverted inputs. So we have the not chip enable and the not write enable. So in order for the chip to be in read mode, write enable needs to be pulled high, okay? So we need to make sure that pin is always high, and chip select, okay, chip enable is active when it's low. So we have to always pull that low. For the Commodore to be able to always read from the chip and always have the chip enabled, it needs to be that way. Okay, so what I did in the past is I just took this write enable pin and I wired it directly to the positive voltage, and I took the chip enable pin and I wired it directly to the ground. So what I did to circumvent that now is I created these jumpers in the back here, okay? And I'm going to take these off really quick, just so that you guys will see here. We have write enable and chip enable. These are 2 jumpers. Now when these are not jumpered, these pins, they're not going anywhere. Okay, they're not being pulled high or low, which is not good for the chip because it won't know how to handle that. So in order for the programmer to function, what we have to do is we have to take these leads here, right? And where they go on the inside pins. One goes to the write enable, and one goes to the chip enable. So in this case, we've got the red wire going to write enable. So all we're going to do is we're going to bring that over here to the programming adapter. We're going to connect the red one to write enable and the orange to chip enable. So what that does is it brings those pins, this programming adapter brings those pins where they originally were on this SOIC28 package. Okay? So then all you got to do to be able to program this is to just put this into the adapter, like that, okay? Okay, so it's in. So once you got that in there, all you do is you take your programmer, and I'm sure everyone has one of these. If you don't, you should pick one up because they're relatively inexpensive and they program just about any EEPROM that you can get your hands on. Not to mention, they also check logic chips. Most of the 7.4 series, they're all in there. You can check and make sure that they're working. There's even some, like, I think SRAM capability for testing SRAM and some other things. You can also program some specific CPLDs. Actually, you can program the GAL chips that you can use to make PLAs with. You can program these in this unit. Okay. The only thing that you can't program, which would have been cool, are the PLDs, the PLAs actually, the programmable the PLS 100N chips, the Philips Synetics chips that you can actually program to be PLAs. I actually have a few of those. I started programming them. I have a different programmer for that, a much more expensive programmer, much older but much more expensive, more capable programmer. But this will be fine for just this. So basically then you just stick that in there, put the thing down, and, you know, go for it. You basically just program it like you would any normal chip. And when you're done, take it out, you remove this. Now you have to be extremely careful to pull and put pressure on all sides equally, because these pins on these chips are very fragile. I mean, all it really takes is to bend one the wrong way just once, and when you try to bend it back, it'll just snap off. And you don't want that. So at some point I'm going to redesign this programming adapter, probably with a ZIF socket. I wanted to keep costs down, which is why I used these instead, and I figured it would be better this way. So if you guys think that you want to spend a little more money and have me put a ZIF socket, I'll have to redesign because the holes are pretty small. I tried to keep this thing as small as possible, but you know what? Function over form. If that's what's required, I'll do it. So I'm going to move this out of the way. And once you're done programming, you just unplug. Okay? Unplug here. Now your write enable and your chip enable pins, they have to go, like I said, write enable needs to go high and chip enable needs to go low. What happens is when you put these jumpers on, it'll pull those to where they need to be. Like write enable, once I connect this jumper, one side goes to the power. And that's what's going to happen here, okay? And then the same thing with chip enable, it's going to go low. So the one thing, the very, very last thing that I wanted to cover here is that the solder jumper, the bridge. Now, I don't know if you guys can make this out very well, but ideally, you will have this selected once you figure out. And I'll have to do a test and make sure that this works with a 2332 configuration. And I'm sure it probably will. If you're writing a 2332, like if you're writing a 4K image, it may work. If you select, I don't know. I'm gonna have to do some testing on that. But what's important here is that it will work if you select a 2364. If you select 2364 by jumpering those two locations on the chip, then you're good to go, okay? And honestly, .2364... yeah, it does require the jumper. Okay, so make sure that's jumpered before you do the programming. And then after you're done with the programming, if you need to change this back to 2332, it's just simple. You take the soldering iron and you jump the other side. So, I mean, these jumpers, they might get in the way a little bit, but, any soldering iron should be able to easily fit, into there. So even if you look here, I can easily go in with my soldering iron and change things around. So there's plenty of space here. Next revision, I might move that solder bridge up to here somewhere. I might have to get rid of my logo, but, like I said, function over form, right? So, back to the jumpers. Once you're good to go, once you've got it programmed and you're ready to use the chip, all you have to do is put these jumpers on. It's a little easier if you've got a set of tweezers, but it's not overly complicated either if you don't. So eventually you'll get it. So there we go. So now all you got to do is take the chip, put it in your Commodore, and you're good to go. You have yourself a chip, and if you later decide, oh crap, I want to use a different kernel image. So you take your chip out, put a different kernel image on it. You want a different basic image? Put a different basic image on it. So it's that simple. So that video is probably way longer than I was going to, hope for, I guess. So you know what I'll do is I'm going to do a very short video tutorial on how to connect this to program it, and then I'll put it in the table of contents so you guys can just click on it if you want the short description. So here is all the pieces, and here comes the short description. The short description basically goes like this. If you receive your chip and your programming adapter kit, your programming adapter kit consists of this and this. your chip will come in looking like this. Your chip, right? Let's move this out of the way. Your chip will come with 2 jumpers, and it will have a solder bridge already set on 2364. So, your chip, the way it's configured now, is ready to be put into a system, whether it has an image on it or not. If it has an image, start using it. If not, well, you need to program it first. To do that, you basically just disconnect the jumpers. It's very easy. There you go. And from here, you're going to want to take the jumper cable and connect the inside pins. Okay? So just the 2 inside pins. It doesn't matter which color is what, as long as you make sure that the other end is the same. So we're going to go with red. And they're marked down here, you'll see. You've got WE and then CE. So right now the way it looks is we've got WE at orange and CE at red. So WE is orange, so we're going to take our programming adapter and we're going to plug in the orange cable to WE. And then CE is red, we're going to plug into that. And then all we got to do is we got to take the chip. And you'll see that the notch up here indicates that pin 1 is here. And we're just going to take it and we're going to plug it in to the socket. Be careful not to bend the pins. They should just go right in. Okay. Now that you have this configuration, you're ready to program. Take your programmer, plug in the socket, clamp it down, program whatever you need. Basic, kernel, character. Unplug. Unplug your cables. Remove your chip very carefully. I can't stress this enough. These pins, they are super delicate. You can't bend them. If you bend them and you try to bend one back, they will break. Okay? Unplug the cable here. Put on the jumpers. It's easier if you've got a pair of tweezers, but still doable even if you don't. It's also better if you've got smaller fingers than I do, but it's the one thing I hate about my hands. My fingers are huge. Alright. There we go. Jumper's on. Now all you got to do is take this and put it in the socket that the image corresponds to that you flashed it with. And there you have it. Those are the instructions. Nothing else to say about that. Hope you guys enjoy the product. If you have any questions, feel free to contact me through the comments, through my email, through my website, through Facebook, wherever you found me, wherever you found the product. I'm always here to help. And yeah, thanks for the purchase. And yeah, so I'll see you guys in the next video.